Okay, thank you. So I'm going to show a very large collaborative work that is mainly done within two main projects, which is the Fixed Line Transit Mediterranean Monitoring Network and the LIFE Conceptumaris. So the LIFE Conceptumaris is an Article 11 LIFE project, which means that specifically aim at supporting the surveillance and the conservation status of the species covered by the Habitat Directive. So at supporting the Article 11 of the Habitat Directive, so the surveillance, but also the Article 17, which means ask member states to report on the conservation status of the species every 6 years. So, but despite this requirement, the last Habitat Directive reporting status say that almost 80% of cetacean species are not assessed. And so the LIFE aim to improve the conservation, contribute to improve the conservation status of the species, try to fill the information gap, especially in offshore areas, setting an international approach for the surveillance and assessment, identifying and mapping the important offshore site for the species, the hotspot of ecological process, but also the risk area and season for two of the main threats for the species, which are maritime traffic and marine litter. And finally, give some indication to identify some suitable mechanism to meet the conservation need. So this study focused on those two main aims. But firstly, we had a look at what the Habitat Directive is requiring. And it's required to assess the status using 4 parameters, which are range, population, habitat for the species, and footer prospect. In this case, we focus on the range, which is asked to be assessed as surface of range, trend and surface, and referring to a favorable reference range. Almost the same parameters are required by another large legislative framework, among which the Marine Strategy Framework Directive, OSPAR, the Regional and Barcelona Sea Convention, but also the IUCN. But all these requirements do not give very clear indication on which method use and which indicators use. There are some guidelines and some reference reports for this. And we get through all these reports, and we come out with 4 potential indicators to be tested for the metrics to be used to assess the range. And these are the observed distribution range, the ecological potential range, range pattern, and the proportion between the observed range and the ecological potential. And so assessing the change in these indicators. So this was the context, and now we were ready to try to test those indicators. And we aim testing these 4 potential indicators, especially to assess the range and habitat short-term trend, so it means between 2 6 years period required by the directive, of targeting 3 low-density deep diver species, which are Grampus griseus, Globicephalus, and Ziphius. And we use the data set collected within the FLT network between 2008 and 2019. And we use also another independent data set for validation, which are the ASE data, the Ketos Maricamp, and the Orca cruise, which we thanks. And so what we did, firstly, we split the data set into 2 periods, almost corresponding to the 3rd and the 4th Habitat Directive reporting cycling, and we used the first period as baseline to be compared over the subsequent period. So going a little bit in detail about the metrics that we use, the observed distribution range was calculated within the 95% isoplex defined by the kernel density estimators. The ecological potential range was assessed using spatial predicted site based on the habitat map models, as it is suggested by the IUCN guidelines. The range pattern was calculated either as surface of overlap and as direction and magnitude of shift between the center of gravity detected on the two periods. And lastly, the proportion of the observed over the potential range was calculated for each period. And all the trends were assessed as percentage difference of values of the second period over the first period, normalized by the effort for what regards the observed distribution range. So, but for modeling the ecological potential range, we did some more analysis, and we tested 5 different modeling approaches. And for traditional regression models and 2 machine learning methods. And model parameters were set after comparison across several combinations of regularization parameters and feature class. And then the modeling parameters were customized and standardized for the goal of comparison among species. The performance of these 6 final models were then compared using 2 threshold independent metrics, the area under the curve and the continuous Bayes index, and also validated through the independent data set. And 3 potential thresholds were tested for transforming the continuous map of ecological potential areas on habitat suitability into binary suitable and unsuitable maps. And at the end, it resulted that all the models performed quite well when tested over the 2 metrics, but maxent resulted the more efficient and reliable when tested over the independent data set. And the equal training, sensitivity, and specificity was the most reliable. And so look at the result. Here you see the Grampus griseus observed the range detected over the 2 periods. So in white, there is the range of the species detected during the first period, in black, the overlapping areas, and in green, the second period. It can be noted that the white is not visible, is almost covered by the overlapping. In the gridded range is instead largely visible, also outside the overlapping areas. And this means that the species was using the previous areas, but also new areas during the second period. And this situation is partially found also for the other 2 species. And so, in general, the common areas of effort highlight an increasing trend in the extent of the observed range, either for Grampus and for the other species. And these are the result of the ecological potential range, in color, the one using all the data set, and again, in black and white, the 2 period and the overlap. And so we can say that, in general, there were a permanence of well-known areas for the species, and with a certain percentage of overlap between the 2 periods. But looking at all the data together, here you have the gridded areas which define the observed range, in red the ecological potential within the area of effort, and pink projected outside the area of effort. This is Grampus, the first period, and this is the second period with the common area of effort. What you can see, there are some changes, as for example, the ecological, this is for the 10 minutes or for the 15? Okay, so I got a little bit of... Okay. Thank you. So the first period, there were an ecological habitat suitable detected in the Gulf of Lyon, which is not anymore detected during the second period. And this situation was found also for the other 2 species. So there were not significant change in the proportion between the observed and the ecological potential for Ziphius, just an enlargement for the Grampus and the Globicephalus. And Some changes were also detected in the niche of the species, as the most important variables for all the 3 species during the first period was, as expected, the distance from the canyon, while during the second period, the species distribution was mostly driven by chlorophyll and depth. So what does it mean, putting all these indicators and this information together? If we were using the observed range distribution only, we would have highlighted an enlargement of the range, which could have been interpreted as positive. And also using the ecological potential range as indicators, we would have not detected any significant change. But the observed proportion of observed ecological potential would have shown also a stable situation. But using the range pattern indicator, it came out a common shift detected in either the observed and the ecological potential range in all the 3 species. And also the fact that the Grampus enlarged the observed distribution over the ecological potential raised attention because it means that the species is pushed outside the ecological niche. And so, after this test, we come out, as usual, with a lot of list of limitations and points to be taken into account, but also with a long list of recommendations. And between these, the most important is that we need to use contemporary indicators to try to understand what is going on and which is the situation. And we probably need to have synoptic analysis on more species with similar ecology together to understand if it's just a change of one species or if it's something more global. And another important point is that probably the 6-year period, which is required by the directive for the assessment, probably is not the most adequate for the species, and is probably too long from a conservation point of view. Indeed, by the time we detected a statistical significant trend, it could be too late for the species. We need a more precautionary approach, as Ben Wurzig was pointing out at the beginning of this conference, and also waiting for detecting the presence or absence of a species from one place. It means too long. The species is disappearing from a species, from an area. So probably we need something else, like Arianna was suggesting, just an encounter or change in encounter rate. And also other aspects need to be taken into account, like form, function, behavioral ecology, vulnerability, and Natasha was pointed out this aspect. So there is still a lot to do, and definitely we need to join efforts together. Okay. Sorry. Thank you.